Okay, on this video, we expand on z-scores and specifically what you're doing when you transfer a problem um, to a z-score. And actually what you're doing is that you're transforming or you're mapping the original problem in terms of an x into a new variable, we'll call it z. And what's cool about the z is that the distribution of z's is actually normal also. And we call this the standard normal. So we have normal distributions and we have the standard normal. The standard normal always has a mean of 0 and a standard deviation of 1. And when you go to the back of the book to solve a problem, you're actually solving a normal distribution problem that's identical in terms of solution to the original problem. So let's go to Excel. This is what we just watched a video on. And if we were trying to solve for the area to the left, let me put a number over here like 13. What is the probability that I would get a number 13 or less on a normal distribution centered at 12 with a standard deviation of 3? So what the back of the book has, when you go to the back of the book, first thing you have to do is calculate a z-score. Well, the z-score is equal to 13 minus 12, that's 1, over 3 to come up with 0.333. And then you could either use the norm dist formula, which is what we know how to do to calculate the probability of getting a number of 13 or less is 0.6306, or you could go to find 0.33 in the back of the book, 0.33, and you could see it's about 0.62, 0.62, so you could see that's where you would, how those numbers are the same. So what you're doing when you calculate a z-score is actually you're redefining this problem on another normal distribution that is centered at 0 with a standard deviation of 1. So here's a standard normal. Here's a standard normal distribution, and it's centered at 0 with a standard deviation of 1. So if I put in 0.33 here, 0.333, then you can see that the area to the left, the probability of getting a number less than 0.33 is 0.6306. And let's put this way out there. There. So that's what this number is, 0.63, or that right there, this area. And that's identical to this problem where you have a distribution centered at 12 with a standard deviation of 3. It's an identical problem if you're trying to solve for the area to the left of 13. It's identical to a standard normal centered at 0 with a standard deviation of 1 and find the area to the left of 0.333. That's why we calculate that z-score, and these are identical problems. So the back of the book has a standard normal distribution. And remember, a standard normal, the mean is always equal to 0. And the standard deviation is always equal to 1. Oh. Equal to 1. That's always true on a standard normal. A normal distribution, it can be any value and it can be any non-negative value. The standard normal, it's always 0 as the mean and the standard deviation is always 1. And so when you solve this problem, you're at the same time solving this problem. Hopefully that adds some more color to the normal distribution and the standard normal. Thanks.